All right, it's time to get ready for our mid-unit test. And so as we work through this, make sure to reach out to me if you have any questions. But number one in this page right here is all multiplying and dividing. With multiplication and division, we don't need a common denominator. We just have to factor everything and see what cancels out. And so on the top left, we have 4 terms. That's going to be the factor by grouping. And so in the first group, I can take out 2x squared, and I'm left with x plus 1. Out of here, I can take out a 3, and we're left with x plus 1. And so the x plus 1s will come together, and we're left with the 2x squared plus 3. On the top right, we've got 3 terms. We'll do the x method, and we'll think what multiplies a negative 15 and adds to positive 2. And so that's going to be a positive 5 and a negative 3. And then we divide by the 1, and so we have x plus 5 and x minus 3. On this one, that's a difference of squares, and so the square root of x squared is x, square root of 9 is 3, so x plus 3, x minus 3. And then from here, we can take out a 2, and we're left with 2x squared plus 3. So that's everything fully factored, and now we'll just cancel out. We've got 2x squared plus 3, x minus 3, and that looks to be it. So we're going to have x plus 1 on top, along with the x plus 5. And on bottom, we have the 2 and the x plus 3. And if you want to check to make sure you got the right answer, there is a way to do it in your calculator. It takes a little bit of time, but in our y equals, we'll put the original equation in our y1. And so I'll put the fraction, 2x cubed plus 2x squared plus 3x plus 3. And then on bottom, x squared minus 9. And then multiplied by another fraction, x squared plus 2x minus 15 over 4x squared plus 6. And then in y2, we'll put our answer. And so we've got x plus 1, x plus 5, and then 2x plus 3. And if we did this correctly, since we just factored it, it should be the same exact graph. And so we could go in the graph, or the easiest way is just go to the table and see, are the numbers the same? There may be a couple of little differences right here, like there's an error and then a number, but everything else we can see is the same. We got 5 over 6, 5 over 6, 3 over 2, 3 over 2, 21 over 10, 21 over 10. And as we keep going, they're the same numbers on both ones, and so we definitely got it correct. And so that's a way to check it in your calculator to make sure you did it correctly. Number 2. We have a division. Anytime we have a division, we're going to flip the fraction that immediately follows and change it to multiplication. And now we'll just factor everything. And so we'll take out a 7x from the first one, and we're left with x plus 3. X plus 7, there's nothing we can do with that. This one we're going to think what multiplies to negative 35 and adds to positive 2. And that's going to be a 7 and a negative 5. And so x plus 7, x minus 5. And then we'll take out an x squared, and we're left with x plus 3. And so we've got x plus 3 on both top and bottom, x plus 7 on top and bottom, and then there's also this x and x squared, so we can take away one of those x's with that one. So we're left with 7 on top, and we've got x minus 5. And if you wanted to check it, you could check it the same exact way we did number 1 in the calculator. Make sure that this graph and this graph are the exact same. Number 3. Again, we're going to have to flip this one that immediately follows the division symbol. Change it to multiplication, so that becomes, this is the sum of cubes, where my a is going to be x, and my b is going to be 3 by doing the cube root. And then we'll plug it into the formula, which, as a reminder, with the sum of cubes, the formula is a cubed plus b cubed, and it can turn into a plus b, a squared minus ab plus b squared. And so we'll just plug in the a and the b into this formula. And so x plus 3, x squared minus 3x plus 9. And then we have the 4x. We can take a 9 out of there to be left with x plus 3. And then we can take a 3 out of there to be left with x squared minus 3x plus 9. That doesn't factor any further, but it does cancel out with that one. That cancels out with that one. On top, we're left with 4x. And on bottom, we're left with 9 times 3, which is 27. Go on, number 4. I'm going to flip this one that immediately follows the division symbol. Change it to multiplication. and now we'll factor. So this one is grouping right here. So we'll take out an x squared, and we're left with 2x plus 3. There's another we can take out of here, so we can put that 1 right there. And so the 2x plus 3's will come together, and the x squared plus 1's will come together. On this one, we've got what multiplies a 28 and adds to 11, and so that's going to be 7 and 4. So x plus 7, x plus 4. And then 4x squared plus 9, that's not going to factor any because it's addition. You can't do sum of squares, just difference of squares. Down here, we're going to think what multiplies a 24 and adds to 10. That'll be 6 and 4. So x plus 6, x plus 4. That's going to be difference of squares, so 4x squared plus 9 and 4x squared minus 9, which will go further. And so we have 4x squared plus 9, and then that's going to go down to 2x plus 3 and 2x minus 3. And then from here we can take an x out, and we're left with x plus 7. So we have a 2x plus 3. No x squared plus 1. We have x plus 7. We have x plus 4. And 4x squared plus 9. So on top we're just left with the x squared plus 1. And on bottom we're left with the x plus 6. And 2x minus 3. And that x. And now we're moving into subtraction. With subtraction, we do have to find, with addition and subtraction, we do have to find the least common denominator. So between 12 and 16, they both go up to 48. If you needed help, you could list out the multiples of these numbers. So 12, 24, 36, 48, 60, and so on. 16 would go 16, 32, 48, and there we go. There, that's where they first meet. And then we have x squared. So this one, to go from 12 to 48, it needs 4, but then we also need an x. And so we're going to multiply the top and bottom by 4x. This one has the x squared, but we need to multiply 16 by 3. And so on the left side, we have 4 times 7, which is 28x. And it is a subtraction. Minus 5 times 3 is 15. Whoops. There's nothing we can do with that, so I'm just going to rewrite it because of the scratch out. 28x minus 15, we'll put the denominator on bottom, 48x squared. And that's it. On this one, there's nothing in common, and so they need each other. So this side needs x plus 5. This side needs the 2x minus 3. And so over here, that's going to be 2x squared plus 16x minus 3x minus 24. We do have a subtraction, and so I'm going to go ahead and change the sign. So it becomes negative 2x squared and negative 10x. And then we'll combine like terms, so the x squareds cancel out. We have 16 minus 10, which is 6x. Oh, whoops. We also have this 3 right here, so that's 13 minus 10, which is 3x. And then minus 24, which if I tried to factor that to go further, I could pull out a 3. And so 3x minus 8 over my denominator, which is 2x minus 3 and x plus 5. And just like we did on the front, we could check this by going in the calculator and seeing, is this equivalent to this? And it should be. And so I'll do it real quick just to show an example, make sure I got the right answer. And so this one is going to be x plus 8 over x plus 5 minus 2x over 2x minus 3. And then our answer was 3x minus 8 over 2x minus 3 x plus 5. And we'll go to the table, and we see everything seems to be matching, and so we did it correctly. So you can always check your answers and make sure that they work in the calculator. All right, this one I'm going to go ahead and factor it and think what multiplies a negative 2 and adds to 1. That's going to be 2 and negative 1. And so x plus 2, x minus 1. They both have x plus 2, but this one needs x minus 1. And so we're going to have x plus 3x minus 3. So that becomes 4x minus 3, nothing I can do with that, over the x plus 2, x minus 1. Sorry, I went off the screen right there. So this one needed x minus 1. I distributed the x minus 1 with a 3. That became the 3x minus 3. Combine like terms to get the 4x minus 3 over the denominator. Number 8, we're doing one more subtraction problem, and so over here we got grouping, and so I'm going to pull out an x squared from the first group, be left with 2x minus 5. Nothing I can do with that one, so plus 1 and 2x minus 5. So that becomes 2x minus 5 and x squared plus 1. Over here I can pull out a 2x, and I'm left with x minus 5, sorry, 2x minus 5. And so they both have 2x minus 5, but they need to share the rest of it. So this side needs x squared plus 1, and this side needs the 2x. And so over here we have 2x cubed plus 4x. This is a subtraction, and so I'm going to go ahead and change my signs. And so it becomes negative 2x cubed, negative 2x, negative 3x squared, and negative 3, and then we'll combine like terms. And so my 2x cubes cancel out. I've got negative 3x squared plus 2x minus 3. And then I don't like my first term to be negative, and so I'll just take out a negative. And that becomes positive 3x squared, negative 2x, and positive 3. And I could try and think, okay, is there anything that multiplies a 9, adds a negative 2? No, I can't think of anything, and then we'll just put my denominator down here. So the 2x minus 5, and the x squared plus 1, all three pieces. Over here, I would think what multiplies a 4 and adds to 5, that'd be 4 and 1. And so x plus 4, x plus 1. Over here, what multiplies a negative 8 and adds to 2, that'd be 4 and negative 2. And so x plus 4, x minus 2. They both have x plus 4, so this one needs the x minus 2. This one needs the x plus 1. And so that's going to become x squared minus x minus 2x plus 2. It is addition, so we don't change anything, plus 10x plus 10. And then we'll combine like terms. We have the x squared. Let's see, that's negative 3 plus 10, which is plus 7x, and then plus 12. And I would think what multiplies a 12 and adds to 7, that's going to be 4 and 3. And so that'll become x plus 4, x plus 3, over my denominators, which were x plus 4, x plus 1, and x minus 2. The x plus 4s are on top and bottom, and so that's my answer, x plus 3 over the x plus 1, x minus 2. All right, now we'll get into the solving. With solving, again, we need a common denominator, but once we do, we'll figure out what x can't be, and then we'll solve in the numerator. And so this one needs a 3, this one needs the x minus 5, and this one needs the 3. And so my LCD on this one was 3 and x minus 5. And if I set that equal to 0, I find that x cannot be 5 because we can't divide by 0. And if I plug in 5 minus 5 is 0. I don't want a 0 in the denominator. And so we're going to go ahead, I don't need the denominator anymore. Now we're just going to distribute on top and solve for the numerator. So we're going to have 3x minus 3 plus x squared minus 5x is equal to 12. Anytime you have x squared, you need to get everything to one side. So we're going to move this 12 over. And so I've got x squared. Let's see, 3x minus 5x is negative 2x. And when I move this 12 over with subtraction, that becomes a negative 15. And then I'll think what multiplies a negative 15 and adds negative 2. That's going to be negative 5 and 3. And so x minus 5, x plus 3 is equal to 0, so x equals 5 and negative 3. But as we found out, x can't be 5, so my answer is negative 3. Over here, this becomes x plus 3 and x minus 3. So this has the x minus 3 and needs the x plus 3. This needs the x minus 3. And so with x plus 3 and x minus 3, if I set equal to 0, we find x cannot be plus or minus 3. Anything else is fair game, but not those two. And so we'll distribute 9x minus 27. This is a subtraction problem, so we're going to change the signs. And then we'll distribute my 2 to get the 2x plus 6. There's no x squared, so we just want x's on one side, non-x's on the other. I'll go ahead and combine like terms first. So 9x minus 2x is 7x. Negative 27 plus 8 is going to be a negative 19. 2x plus 6. Let's see, and then we'll subtract the 2x over to get the 5x. We'll add the 19 over to get the 25, divide by 5 to get x is equal to 5. And with this one, like we've done before, I haven't showed how to check one of these, but if I got x equal 5, I can do like we've done before, where I store 5 in for x, and now we just check it with this original problem. So I'm going to have alpha y equals 9 over x plus 3, and we got subtraction, 2x minus 8 over x squared minus 9 equals, and equals 1, so we'll do the other side as well. 2 over x minus 3 equals 1 on both sides, and so it checks. 5 is the correct answer. All right, I need to factor this one, and so what multiplies a negative 8 and adds to 2, that's going to be 4 and negative 2. So x plus 4, x minus 2. And so this one needs the x plus 4, this one needs the x minus 2, and we know x cannot be negative 4 or positive 2 based on those denominators right there. And so now I'm going to distribute the 1 to get x plus 4 is equal to 2x plus 1 plus 2x minus 4 by distributing that 2 over there. I'm going to combine like terms over here. X plus 4 equals 4x minus 3. And now I want to get x's on one side, non-x's on the other. And so I'll move the x over to get 3x, move the 3 over to get 7, divide by 3, so x equals 7 over 3. It doesn't conflict with one of those, and we could check our answer and make sure we got the right answer. Number 13, it's monomials on the bottom, and so I don't have to multiply by each other, but we want to see where can they have common ground. On this one, it's going to be 12x. 3 and 4 both go up to 12, and so I know x cannot be 0. To make this go up to 12x, I'm going to multiply by 4x, I'm going to multiply by 3, and I'm going to multiply by 12. And so it becomes 4x. We're going to change the signs because it's subtraction. So negative 3x plus 18 is equal to 24. 4x minus 3x is x. I'm going to move the 18 over to get 6. It doesn't conflict. Looks pretty good. And I'll go ahead and check it just to make sure I got the right answer. I know I didn't check the previous one, but 6 stored into x. And then we have 1 over 3 minus x minus 6 over 4x, that equals, and then the other one, 2 over x equals 1/3. They're equivalent on both sides, and so we did it correctly. The pressure of a gas at constant temperature varies inversely, and so that's where we do the x1, y1 is equal to the x2, y2. As the volume V, if the volume is 450 when the pressure is 30, so we're going to multiply those two together. That's my first set. Find the pressure when the volume is 750. And so we'll divide by 750 to whatever we have over there. So we'll go into our calculator. 450 times 30 equals, divided by 750, 18. And so x equals 18. And we're talking about pressure, which is pounds per inch squared. And last one, the time varies inversely. So again, we're doing the same equation as the number of people work. The time it takes Luke and Larry to complete a task is 15 hours. So Luke and Larry, that's 2 people, 15 hours. How long would it take if they recruited 3 more people? So it's Luke, Larry, and 3 more people. That's 5 total people. And so we'll divide by the 5, and we can put that in the calculator. 2 times 15 is 30, divided by 5 is 6. And that's it for this review. If you have any questions, make sure to let me know. Make sure you're ready for Thursday. You all have a good one.